Welcome students. Today we discuss about MCQ type of questions, chapter 1, relations and functions. Question 1. Let T be the set of all triangles in a plane with R, a relation in T is given by R equal to set of all T1, T2 such that T1 is congruent to T2. Then R is subdivision A reflexive, subdivision B symmetric, subdivision C transitive, subdivision D equivalence relation. Listen. Let T1 belongs to T, set of all triangles. Then triangle T1 congruent to T1. Every triangle congruent to itself. So T1 congruent to T1, which implies T1, T1 belongs to R. Therefore, R is reflexive. R is reflexive. Next, let T1, T2 belongs to set of all triangle T. Then T1 congruent to T2, which implies T2 congruent to T1, which gives T1, T2 belongs to R, which implies T2, T1 also belongs to the relation R. Therefore, symmetric. Relation R is symmetric. T1, T2, T3 belongs to set of all triangles. T1 congruent to T2, T2 congruent to T3, which gives T1 congruent to T3. That is T1, T2 belongs to R. T2, T3 belongs to R, which implies T1, T3 belongs to R. So the relation is reflexive, symmetric, and this is transitive. So if the relation is reflexive, symmetric, and transitive, then the given relation is equivalence relation. So option D is the correct answer. Second question. If R1 and R2 are equivalence relations in a set A, then R1 intersection R2 is subdivision A reflexive, subdivision B symmetric, subdivision C transitive, subdivision D equivalence relation. Listen. Given R1 and R2 are equivalence relation in a set A, consider A, consider A, belongs to the relation R1 and A comma A belongs to the relation R2. This implies A comma A belongs to R1 intersection R2. Therefore, R1 intersection R2 is reflexive. Let A comma B belongs to set A. A comma B, the ordered pair A comma B belongs to the relation R1 and A comma B belongs to the relation R2. Which implies A comma B belongs to R1 intersection R2. Also B comma A belongs to R1, B comma A belongs to R2, which implies B comma A belongs to R1 intersection R2. So A comma B belongs to R1 intersection R2, which gives B comma A also belongs to R1 intersection R2, therefore symmetric. Therefore, the given relation R1 and R1 intersection R2 is symmetric. Third one, let A comma B comma C belongs to a set A. The ordered pair A comma B belongs to R1 intersection R2 and B comma C belongs to R1 intersection R2, which gives A comma C belongs to R1 and A comma C belongs to R2. This implies A comma C belongs to R1 intersection R2. So A comma B belongs to R1 intersection R2, B comma C belongs to R1 intersection R2, which gives A comma C belongs to R1 intersection R2, therefore transitive. So the relation is reflexive, symmetric and transitive, hence the relation is an equivalence relation. Option D is correct answer. Next question, let a function defined from x to y, a relation defined in x is given by R equal to set of all A comma B such that f of A equal to f of B, then R is subdivision A reflexive, B symmetric, C transitive and D equivalence relation. Solution, for every element A which belongs to capital X, f of A is equal to f of A. F of A is equal to f of A, which gives A comma A belongs to R. Therefore reflexive. The given relation is reflexive. Then A comma B belongs to R, which gives f of A is equal to f of B, which implies f of B is also equal to f of A, which gives B comma A belongs to R. Therefore, R is symmetric. Relation R is symmetric. Let A comma B belongs to R, B comma C belongs to R, which gives f of A is equal to f of B and f of B is equal to f of C. From this we get f of A is equal to f of C. This implies A comma C belongs to R. So A comma B belongs to R, B comma C belongs to R, which gives A comma C belongs to R. Therefore, R is transitive. R is transitive. So hence the relation is reflexive, symmetric and transitive. Hence the given relation R is an equivalence relation. Option D is the correct answer. Fourth question, if n of A is equal to P, n of B equal to Q, then the total number of relations that exist from A to B is 2 to the power PQ. So the answer is subdivision A, 2 power PQ. Fifth question, let the relation R is equal to the set of all A comma A cube such that A is prime less than 5 be a relation. Then the range of R is subdivision A, set 2 comma 3, subdivision B, set 4 comma 8, subdivision C, set 8 comma 27, subdivision D, set 9 comma 27. Listen, given the relation R is equal to A comma A power 3. A is prime, A is a prime less than 5. A is a prime less than 5. So A is a prime less than 5. Okay, then the relation R contains the elements 2 comma 8, 3 comma 27. So the range of R is equal to set of all the second elements 8 comma 27. So our answer is C. Sixth question, C, let R, the relation R is equal to set of all x comma y such that x belongs to natural numbers x less than 5 comma y is equal to 3 be a relation. Then the domain of inverse relation is subdivision A, set 1, 2, 3, subdivision B, set 2, 3, subdivision C, a singleton set 3, subdivision D, set 1, 2, 3, 4. Solution. In the relation R, see the set x comma y, x belongs to natural numbers and x is less than 5 and y is equal to 3. So relation R contains the elements 1, 3, 2, 3, 3, 3, 4, 3. That's all. Okay. R inverse relation contains the elements 3, 1, 3, 2, 3, 3, 3, 4. So therefore, domain of R inverse is equal to 3. The singleton set 3. So subdivision C is the correct answer. So domain of R inverse is equal to 3. So since in the relation the first element for all the elements is 3. Seventh question. Which of the following is not an equivalence relation on Z, set of all integers? Subdivision 1. R equal to set of all a comma b such that a plus b is an integer. R equal to set of all a comma b, a minus b is an integer. Subdivision C. R is equal to set of all a comma b such that a is equal to b. Subdivision D. R equal to set of all a comma b such that b greater than a. See that clearly in subdivision A, if a plus b is an integer, okay, a plus a is also an integer, it's a reflexive, and a plus b is equal to b plus a, so symmetric. So a plus b is an integer, b plus c is also integer, so a plus c is also an integer. So in the relation R, in subdivision A, all the three relations are satisfied. Similarly, in subdivision B, all the three relations, reflexive, symmetric, transitive, are satisfied. And subdivision C is also an equivalence relation. But see, in the subdivision D, B is greater than A. For example, take an element 1, 1, take an element 1, 1, which does not belongs to the relation R, since 1 is not greater than 1, it not satisfies the inequality. So the reflexive relation is not satisfied. Similarly, symmetric relation is also not satisfied. If B greater than A, which does not imply A greater than B. So symmetric relation is also not satisfied. So in subdivision D, the set of all A comma B such that B greater than A is not an equivalence relation. Subdivision D is the correct answer. The relation R is not an equivalence relation. Next we go question number 8. Let R be the relation over the set of all straight lines in a plane such that L related to M, straight line L related to another straight line M, if and only if, what is the relation? That is L perpendicular to M. Then R is subdivision 1 reflexive, subdivision B symmetric, subdivision C transitive, subdivision D an equivalence relation. So in this question, L is not perpendicular to itself. L comma L does not belongs to the relation R. L comma L does not belongs to the relation R. Since a line L does not perpendicular to itself, so it's not a reflexive. L comma M belongs to the relation R. L is perpendicular to M, which gives M comma L will also belongs to the relation R. M is also perpendicular to L. Okay, so L perpendicular to M, which gives M perpendicular to L. So therefore, the given relation is symmetric. So for first one, not reflexive. The second one, symmetric. See the third one. L is perpendicular to M, line L perpendicular to M, and M perpendicular to another line N, which does not imply L perpendicular to N. In this case, L is parallel to N, so not transitive. Not transitive. So in this question, the relation R is not reflexive, not transitive, so that it's not an equivalence relation. The correct answer is the relation R is symmetric only. Ninth question. If R is a relation on the set 1, 2, 3 defined by R equal to set of all 1, 2, then the relation R is transitive. The relation R is transitive. So in question number 10, the relation R is two, 1, 3, 1. 2, 1, 3, 1. So the relation R contains only two elements, 2, 1 and 3, 1, because the relation is x is greater than y, given x greater than y. Given that x greater than y, so the relation R contains the elements 2, 1 and 3, 1. So range of y. Range of y is 1. So subdivision C is the correct answer. See the 11th question. A relation R is defined from set 2, 3, 4, 5 to the another set 3, 6, 7, 10 given by R is equal to set of all x, y, R equal to set of all x, y such that x is relatively prime to y. X is relatively prime to y. Then the domain of relation R is the relation R contains the elements 2, 3. 2, 3 is relatively prime. 2, 3 is relative prime. 2, 7. 3, 7. 3, 10. 4, 3. 4, 7. 5, 3. 5, 6. 5, 7. So the relation R contains these elements. X is relatively prime to y. 2 is relatively prime to 3. Similarly 2, 7, 3, 7, 3, 10, 4, 3, 4, 7, 5, 3, 5, 6 and 5, 7. So domain of the relation R is equal to 2, 3, 4, 5. So subdivision D is the correct answer. Twelfth question. A relation R from C to R. C denotes set of all complex numbers to real numbers, defined by x related to y if and only if modulus x is equal to y. Which of the following is correct? First subdivision 2 plus I3 related to 13. Second subdivision 1 minus I related to 4. Third subdivision 1 plus I related to 2. Here 1 minus I related to 4. 1 plus I is a complex number related to 2. Minus I related to 1. Subdivision D. Listen here. Modulus of 2 plus I3. Modulus of 2 plus I3 is equal to square root of 2 square plus 3 square, which is equal to square root of 4 plus 9, which is equal to square root of 13. Okay, so 2 plus I3 is not related to 13. Similarly, 1 minus I is also not related to 4. 1 plus I is also not related to 2. Minus I, listen here, subdivision D, modulus of minus I is equal to square root of, there is no real part, so 0 square plus 1 square, which is equal to square root of 1 is equal to 1. So therefore minus I related to 1. So as per given information, given relation, x related to y if and only if modulus of x is equal to y. Here your x belongs to complex number and your r is real numbers. So minus I related to 1 is the correct answer. Thirteenth question. Let R be a relation on a natural numbers defined by R equal to set of all x comma y such that x plus 2y is equal to 8. Then the domain of the relation R is the relation R contains the elements which satisfies the equation x plus 2y is equal to 8, where x belongs to set of all natural numbers. So your R contains (2, 3), 4, 2, 6, 1. It satisfies the equation x plus 2y is equal to 8. So the relation R contains 2, 3, 4, 2, 6, 1. So domain of the relation, domain of relation R is the set 2, 4, 6. Set of all the first elements 2, 4 and 6. So option C is the correct answer. Option C is your correct answer. 14th one. If R is a relation on the set A is equal to 1, 2, 3 given by R equal to 1, 1, 2, 2, 3, 3, then the relation R is reflexive, symmetric, transitive and equivalence relation. See, given relation R is equal to set of all 1, 1, 2, 2, 3, 3. Okay, it satisfies all the properties reflexive, symmetric, transitive, and hence the given relation is an equivalence relation. Also, this relation is the smallest possible equivalence relation. This relation is also called smallest possible equivalence relation for the set A equal to 1, 2, 3. 15th question. Question number 15. In the set Z of all integers, which of the following relation R is not an equivalence relation? First subdivision, x related to y such that if x less than or equal to y. Second one, x related to y such that if x is equal to y. Third subdivision, x related to y such that if x minus y is an even integer. And fourth one, x related to y such that if x congruent to y mod 3. X congruence y mod 3. So in this question, option A is correct answer, because x less than or equal to y, which does not imply y less than or equal to x. That is, x comma y belongs to the relation R, but y comma x does not belongs to the relation R. So the symmetricity condition not satisfied. So the given relation R is not an equivalence relation. Subdivision A is your correct answer. And remaining all the three subdivisions are satisfies all the three relations: reflexive, symmetric, and transitive. For subdivision 2, x is equal to x, y is equal to y, so that it satisfies reflexive. X is equal to y, which gives y is equal to x, and also it satisfies the transitive. X is equal to y is equal to some z, then x is equal to z. Satisfies all the relations. Similarly, subdivision C, x minus x is also an even integer, x minus y is an even integer, y minus x is also an even integer, it satisfies the symmetric, and x minus y is an even integer, y minus z is an also even integer, which gives x minus y is also an even integer, satisfies all the three relations. So subdivision C is also an equivalence relation. Similarly, subdivision D is also an equivalence relation. So the first subdivision is not an equivalence relation. Question number 16. Find the domain of the relation R defined on set of all integers as follows. R is equal to set of all x comma y such that x square plus y square is equal to 25. So we are going to find out the domain of the relation. So given R equal to set of all x comma y such that x square plus y square is equal to 25. Is 25, and your x square is equal to 25 minus y square, and your x is equal to plus or minus square root of 25 minus y square. So the possible values of x 0 plus or minus 3 plus or minus 4 plus or minus 5. It satisfies the equation x is equal to plus or minus square root of 25 minus y square. So domain of R, domain of the relation R is equal to 0, plus or minus 3 plus or minus 4 plus or minus 5. So option C is the correct option. Question number 17. If A1, A2 belongs to relation R and A2, A1 belongs to the relation R, for all A1, A2 belongs to A, then the relation R in a set capital A is said to be symmetric. It's a definition. Next question, question number 18. The relation R in the set 1, 2, 3 given by R equal to 1, 2, 2, 1, 1, 1 is first subdivision symmetric and transitive but not reflexive. Second subdivision reflexive and symmetric but not transitive. Third subdivision symmetric but neither reflexive nor transitive. Fourth one, an equivalence relation. See here, in a set 1, 2, 3 given set is 1, 2, 3. One, 1 is there, but 2, 2, 3, through not in the relation R. Therefore, it's not an reflexive. 1, 2 belongs to R. 2, 1 belongs to R. And 1, 1 is there. 1, 1 belongs to R. So therefore, it's symmetric. 1, 2, 2, 1 belongs to R, which implies 1, 1 belongs to R. So the given relation R is not reflexive, but it is symmetric and transitive. So subdivision A is your correct answer. Nineteenth question. If each element of A is related to itself, then the relation in a set capital A is called reflexive. Let A, small a belongs to capital A, then A, belongs to R, then A, belongs to the relation R. So each element of a set A related to itself, then the relation is called reflexive. Question number 20. Let R be a relation on the set capital N of natural numbers defined by N related to M. If N divides M, then the relation R is subdivision A reflexive and symmetric, subdivision B transitive and symmetric, subdivision C equivalence relation, subdivision D reflexive symmetric but not reflexive transitive but not symmetric. So given relation is N related to M if and only if N divides M. Let N belongs to a set of all natural numbers. N divides N, which gives N related to N. Therefore, reflexive. Therefore, the given relation R is reflexive. Let n comma m belongs to n. N related to m, which gives n divides m. N divides m. But m does not divides n. This implies your m is not related to n. Therefore, R is not symmetric. Next one, let L comma m comma n belongs to natural numbers. L related to m, which gives L divides m. M related to n implies m divides n. Then L divides n, which implies L related to n. So L related to m related to n, we get L related to n. Therefore, the given relation is transitive. So, in this question, R is reflexive, R is transitive, but R is not symmetric. So, option D is the correct answer. Okay students, to go through all the 20 questions. These questions are important multiple choice questions. It is very useful to your board examinations. So all the best students. Thank you.